There we go. Hey. All right. So, me and Lake, we're on our way to, well, I don't even know if we're allowed to say. A place that makes alkylated naphtha wings.
Yeah, we're going to a really cool place.
Yeah. So, anyway, I thought we'd use the chance. We're just grabbing coffee in the morning. So, I don't know, a little coffee chat. So, Lake is obviously involved heavily in all things engine oils, whereas I'm more on the industrial side. But I thought it'd be really cool to talk about some of the new technologies, I guess, that Lake is getting to see.
Yeah.
Like what stuff is exciting you at the moment?
Well, it's kind of interesting that with the whole EV push, right? Then there's been some realizations about, there are some downsides.
Yeah.
And so there's kind of been a renewed focus on internal combustion engines with, a little bit of a...
This is us?
This is us, yeah.
Cool.
With a little...
Yeah.
Yep.
Hang on, I'll turn it off for the moment.
Okay, you gonna have the same?
Yes, sir. Quad shot Americano.
4 shots of medium latte?
Yes, please. Do you remember that I ordered from yesterday? That's awesome.
This guy's amazing,
Yeah. So, if anyone is ever wondering how Lake has so much energy in the
You just heard it.
You just heard it.
Yeah.
Quad shot. That's like absolute insanity.
Yeah. Race gas.
Yeah. Like
No, but
literal rocket fuel.
Yeah. But like we were saying, so there's been a renewed interest in internal combustion engines with maybe a different approach.
Yeah.
How can we have, less carbon emission, better fuel efficiency, greater power density? So, like we talked about yesterday a little bit, just here in this area, there's a company that's making a reverse rotary engine. So when I say reverse, so everyone thinks that we're a rotary, they think of the Wankel. But the Wankel is essentially a tri-lobe rotor within kind of a kidney bean shaped housing. The X engine flips it around. So it's a kidney bean shaped rotor inside an X or a triangle shaped housing, which means there's 3 distinct combustion chambers that do not move. So what's cool about that is because it doesn't have that big, long, moving combustion chamber, you get really high compression. So they can actually run it on hydrogen, they can run it on diesel, they can run it on ethanol or whatever they want to run it on. And that super high compression gives them greater power density. And because it's so small, you get really good complete combustion. You don't have those tail ends that really never burn.
Yeah.
So the emissions actually are much lower than a Wankel rotary.
Yeah.
Now, it still has to have some pre-mix, some lube, but what they're working on right now is a way of doing like injection,
Yeah.
like there are in some 2 cycles now. So you're not doing pre-mix, you're just doing oil injection, just so you have enough oil for the apex seal.
Interesting. So in that instance,
And I was actually thinking about something last night. We talked yesterday. I was like, there's some pretty clever chemistry they could probably put in and actually be able to reduce the total amount of oil even needed on the injection so that you have really clean burn, no smoke, very low emissions out of this. That's just one idea that's pretty interesting.
So from a lubrication standpoint, so you mentioned, obviously you've got some in the premix, so that looks a little bit like 2-stroke. But in that instance, the crankcase oil, right?
Yeah.
That's very different because there's no real interaction at that point with the combustion gases.
No.
So you can make a crankcase oil that is kind of resembles an industrial lubricant, right?
Yeah.
At that point. Like no TBN, really, you don't really need that.
Yeah. So Liquid Piston is the company making this engine. And one of the things that's really neat about it is they've got a really interesting side seal for that kidney bean shaped rotor style. And it's actually a 2-piece ring, actually, piston ring kind of thing. So because how good that double seal is, then there's a double lip seal on the crankshaft.
Yep.
Yet nothing gets in. We ran 50 hours and there was really no change in tan, no change in oxidation, no change in wear metals. It's basically nothing.
Yeah.
So you could probably get away with them more like an industrial lube in the crankcase because it doesn't need to be a traditional engine oil. So, that's just one engine concept that I've come across here recently. It's pretty interesting.
That oil kind of probably looks a little bit more like a screw compressor oil, right?
Yeah.
Or something like that, in the sense that, you know, if you think about a lot of the turbine and compressor oils, those things are designed to last 10,000, 12,000, 18,000 hours.
Yeah.
You know, the primary reason why we can't do that with the engine oils is because the amount of contamination that you get from combustion, right?
Yeah.
Soot, water, you know, all of the, or even for the fuel dilution, right?
Yeah.
Is a huge problem. But if you don't have that, if you eliminate it, then yeah, the lubricant system looks entirely different, I guess. Huh, interesting. All right, anything else?
Well, so what we talked about yesterday again was there's another engine. This guy, the company's called Aqua Stroke.
Keep an eye on these guys. This is awesome.
They're just taking an existing engine and they're retrofitting it. But what they're doing is they're running on a mixture of 70% water, 30% ethanol as the fuel.
More water or less?
No, that's perfect.
Speaking of fuel,
More coffee, less water is the better way to go, I think. You know.
You didn't know it's just coffee.
And I'll grab a bagel too. Plain bagel would be awesome.
okay. Here we go. All right.
The important
now
part of the
we've
day
got-
is now
that's the
taken
most
care of.
important.
Yeah.
Thanks, Blake.
Yeah. So Aqua Stroke.
Yeah.
Yeah, 70% water, 30% ethanol. So what they're doing is basically you're burning the ethanol, which will then vaporize the water, so it's like a steam engine.
That's yeah. So when I heard this concept, initially that didn't make any sense. Like, how can you burn water? But yeah, so using the ethanol to generate the heat of combustion, which then vaporizes the water, which as it then turns into steam, obviously the volumetric expansion is what's giving you the power stroke.
Yeah.
That's like extremely cool.
Yeah.
Now, we like to talk about the lubrication challenges.
And it is a challenge.
Yeah. All of a sudden, you're having to deal with a humongous amount of water mixed with ethanol. All right. So I can imagine mix of water and ethanol is going to make everything acidic.
Yep.
Water itself tends to run you into corrosion issues. Now, when you're at high temperature, while you're running, it's probably not so much of a concern. But as soon as you shut the thing down,
That's really the concern.
Yeah,
When they just crank it up and just let it run, they really don't have any problems.
all right, here we go. Now, I should stress, this is not Lake's car. This is a loaner from King Industries. Yeah, so I imagine, when it's cold, the corrosion issues that you potentially run into, challenge.
Yes. I mean, so it was again, quite fascinating that as long as the engine's running, everything's really pretty easy. I mean,
Yeah.
of course, we had to work really hard with coatings. So it's not a normal iron bore. It is a Suma bore, plasma spray bore type that has a titanium nitride alloy to it. So and then the piston rings are stainless steel with a very unique coating that will be compatible with said bore material. Because basically you can't have anything that has a really high propensity to rust in there, otherwise it will. But while it's running in, not much of an issue. The oil itself, PAO ester blend right now with some call it pretty traditional anti-wear and AO type components in it. 'Cause it's not a DI package. That's one of the things that I ended up getting involved in it. Because there is no DI package you can use for this, because it has dispersants and detergents in there that are going to emulsify all the water. My background doing racing stuff and doing everything by component blend is how I ended up getting involved in the project.
Yeah.
We had to make something that doesn't have a lot of things in it that are normally in oils, but still make it where it can lubricate and do a good job. And so that's what we ended up doing. It's pretty interesting. We were talking to the guys at King yesterday about, how can we bring in a corrosion inhibitor that isn't going to cause emulsion problems?
Yeah, so you need and King sell a it's a calcium sulfonate that is a rust inhibitor and often used as a demulsifier.
See, that would be perfect.
Yeah, which I'm a big fan of that product actually. The calcium sulfonate. It's slightly different to the other calcium sulfonates because it has kind of like the double benzene ring that the alkylated naphthalene is known for. That kind of gives it some different properties. It is, I would say, it's pretty rare because I don't think it appears in that many packages. But I've used it a fair bit in some industrial oils, and it works really well. Yeah, that's interesting. So what you've described, I mean, the PAO ester blend with a little bit of anti-wear, probably some rust and oxidation inhibitors. Funnily enough, that's what you've basically described is a synthetic steam turbine oil. Right? So, that's so interesting. And obviously, steam turbines, right? They run into exactly the same issues. Probably not to the same extent. They don't have as much water exposure as you're going to have, but they do run into the issue where if you get steam past the gland seals, some water ingress is going to happen into the oil system, and so they need to have really good demulsibility properties. Wow, that's fascinating. How about in the regular engine oil world? Because I feel like that's an area where, let's say we're going to SQ pretty soon. It didn't feel like that momentous a change, really, right?
No, it's kind of like from SM to SN, right? It really is. It's more of just like a tightening of existing specs, where SQ or SP was such a massive change because almost the entire slate of engines changed.
Yes. Yeah.
And that's what made it such a big deal, was that just massive overhaul.
That's why we needed SN Plus too, right?
Right.
That sort of intermediate.
It was a step
just to cover us off on LSPI.
Yep.
Yeah. Okay. But yeah, it kind of felt a little bit not a letdown. That's probably not the right word, but much more incremental.
Yeah.
I think the challenge that we both discussed it is that with engine oils, the chemistry box is very restrictive on what you can formulate with at the moment if you want API certification. And it's not until you get into things like the race engine oils or these kind of new technologies for combustion that you're really starting to play around with different lubricant chemistries.
That's 100% true. And I think part of that was that with the advent and moving forward of EVs, I kind of feel like the idea was, well, we got to do these tests, we got to make this spec change because this is it. This is the last one. Yeah. There's not going to be a whole lot more to come. Yeah. So we got to kind of take care of this, future-proof ourselves, then we're going to go turn our attention into creating all these things.
Yes.
So it'll be interesting to see, does this swing back and is there a renewed interest in what happens with this? Like, especially if some of these other technologies, if they really take hold. I mean, perfect example. Let's just say, just throw it out there, right? What if hydrogen actually becomes a predominant fuel source?
Yeah.
That's going to change things as well.
Yep.
That is going to be a different path. There's going to need to be new tests and new things around that. Or if some of the stuff I saw, last fall at ASME, people are talking about using ammonia as fuel because it's liquid. It doesn't have the issues. And the concept there is you would have a small tank of hydrogen on board. And basically what you do is you're bubbling the hydrogen through the ammonia because ammonia doesn't really want to light.
Yeah, okay.
But if you infuse it with hydrogen, now you can get it to light.
Now, I had a question about ammonia engines. I've asked this a couple of times, but people haven't really given me a clear answer. Because the way I look at it, and because ammonia is being looked at so strongly in the marine industry,
right?
They all
and that's where this was being driven from. Is that targeted. Marine, local trains. Yep. So everyone that has basically big diesel engines, where they're not rebuilding the engines or not, this is not a easy change. They're like, we're not packing tanks of hydrogen.
Yeah.
Not going to happen.
Yep.
But if we need to be zero carbon, ammonia looks to be
Possibly a solution.
possibly a solution.
So the only thing about ammonia is, though, that as a fuel, very different to all the other products that we're used to. So let's say, for example, marine engine oils.
Mm-hmm.
You know, TBN 100 used to be pretty typical. Now, with some of the sulfur being removed because of IMO 2020, now you got sort of TBN 70, 50. It's starting to creep down. Still very high TBN oils. But if you get any kind of fuel dilution, ammonia is a base.
Right.
So are we going to have to start making acidic marine engine oils?
I mean, it's just kind of the crazy stuff, right? I mean, like you said, and it's not a bad thing, but internal combustion engine oils, you know, all the API stuff, all the ASEA stuff, pretty tight box, pretty well defined. Just not a lot of, we'll call it wild innovation going on there. I think these alternative platforms in terms of architecture for engines, alternative fuels, this is going to create a whole new thing. You know, as someone that loves engines and loves engine oil, that's exciting stuff. You're like, 'cause you just don't know. And I think that's going to be the fun part, is to show up and not show up with preconceived notions. And probably the best thing to do, if you can find a development partner in one of these, is to start from scratch and, you know, really only put in the stuff that the engine actually needs. Not just bring in legacy and say, well, we've always used all these things, so we have to, and then only subtract out what you need to pass. I'd almost say start from base oil and then just work forward.
It's kind of cool to see potentially component formulation coming back in the sense that, you know what, like the last 10 years has all been DI packages. It's kind of boring, to be honest.
Absolutely.
To be honest.
Yes.
And it would be really cool with some of these new technologies to say, well, we've got to rethink the entire chemistry. Let's kind of rebuild it from the ground up. And like you said, you know, we can delete a whole bunch of stuff potentially.
Right.
Which,
Well, a perfect example. To the Aqua Stroke engine. When you're running with water and ethanol, you do not need any deposit control additives because there are none. There's just no need for dispersant. There's really no need for detergent, you know, for what their normal uses are. We do need rust inhibitors. We do need some anti-wear. But like I've even talked to them, the amount of anti-wear you need could be greatly reduced if you added different coatings to different parts of the engine. You know,
well, I mean, anti-wear is not even designed to interact with things like DLC coatings and stuff, right?
It doesn't really.
Yeah.
I mean, so it's like actually, ZDP, if you put too much ZDP, it actually works against the DLC. DLC doesn't typically like that. Certain molybdenums, it will like, you know, certain MODTC combinations, it will work synergistically with it. But yeah, you could run ashless chemistry completely with DLC. And if you've got, if you have DLC on DLC contacts, you don't need anywhere additives at all.
That's so cool.
And that's what's neat, is like you could literally have an ashless formula potentially that could do everything you needed to do.
That's really cool. And I mean, in combination with some of the new kind of treatment, filtration technologies, again, which will probably end up pulling across from the industrial world. I mean, oil life could effectively be infinite on some of these engines, which is neat and probably puts us more into sort of like the condition monitoring world that you would see on a lot of industrial plant. So,
well, yeah, think about the X engine from Liquid Piston. That crankcase oil, done right. I mean, I don't know. I mean, if it didn't change at all in 50 hours, I mean, 5,000 hours. I mean, that wouldn't seem like that's impossible. You know.
So, I mean, you're pretty well connected inside of like the racing world. How about, you know, in any of the major formulas that you kind of have exposure to. Is there anything in like rule changes that are coming up and that sort of stuff, which is, driving kind of innovation that you can talk about?
Well, the opposite is happening in NASCAR.
Yeah, right. Yeah, good point.
So NASCAR is wanting to homologate all the engines, everything for 2026. And the proposed way they're going to regulate that is put the torque sensors on the drive shafts of the car.
Yeah.
So they're actually measuring how much power is in the vehicle during the race.
Yeah.
So there wouldn't be like, oh, well, we homologated the engine, but now we got this really super cool oil we can put in, and then therefore we've gotten around the system.
Yep.
Nope. So it's like, oh, here, what you have is what you have. Just you need to have good durability, and that's it. So kind of crazy. Yeah, so that's kind of disappointing that some of the innovations being taken away. At least in say like Formula One, there's, they're going with the new rules with the sustainable fuel. The fuel change always will kind of have some kind of impact on the lubricant as well. Yep. And what they're doing with that.
Now, something you said the other day, which was super interesting, was the fact that it used to be the MGU-K and the MGU-H, right, which was the hybrid drivetrain was driving all the innovation in F1.
Right.
Now, interestingly, in the new 2026 rules, the power that we're getting out of the hybrid system is capped.
Right.
Right. So, in a weird way, the way that it's incentivized is that the electric drivetrain, because it's become standardized, every team is actually pouring all of their R&D efforts onto the engine side.
Right.
Which is like the opposite of effect of what they desired.
It was the unintended consequence. Like, oh, here we're going to make this simpler. We're going to give you more power from the hybrid unit.
Yep.
That way, it's more electrified and all that. But everyone basically said, well, then we're all going to be the same.
Yeah.
If it's just an energy flow,
yes,
then everyone's the same.
Yep.
Only innovation could be weight, but there's a minimum weight for the car, and they're like, oh well, there's no scope for advantage there.
So you can kind of like tweak little bits and pieces, kind of at the edges, but if there are going to be any kind of like major differentiators between the teams, it's actually going to be on the engine side.
Right. It didn't take them very long to figure out. Yeah, there's no real advantage. There's not a lot of stuff on the electric side. The engine side's everything, and now that we don't have the hybridized turbo, it's just a regular turbocharger, V6. You have to extract every ounce of power you can out of the engine. And of course, we're going with sustainable fuel. So we got a new fuel that has to be net carbon zero fuel.
Yeah.
As combustion. So now it's like all on with that. What does that mean? What does that look like?
Yeah.
And it is absolute craziness, because no stone is being left unturned in terms of coatings, materials. These are going to be, they are the most expensive engines that will ever be built, because they are literally building them out of unobtainium.
Yeah. And I guess from a lubricant standpoint, that's going to drive a fair bit of innovation there, because even if it's only getting a horsepower here and there,
every bit counts.
That is what wins races, right?
Right.
And that's really cool to see. All right, so that was coffee time with Lake, which is good. We should unfortunately, being that I live on the other side of the world, it means that we don't get to do this very often.
No, but we got to do it today, which is good.
Yeah, it was awesome. So
and the coffee here is great.
Yeah. If anyone, I don't even know what the store was called.
Cafe Aroma
in Norwalk.
Yes, highly recommended. Paul was the guy behind the counter.
Yeah.
He remembered our name. I don't remember our name. He remembered our orders from yesterday.
Fantastic coffee. Anyway, obviously everyone on my channel is huge fans of Lake's channel. If somehow you are not subscribed to the Motor Oil Geek, which is like no one at this point, make sure you subscribe. Anyway, we'll catch you another time.
See you.